Welcome to this session, folks. My name is Denzil Ribeiro. I am a principal program manager in the Azure data team, focused on hyperscale. Today we are going to be talking about query store hints. And this is really applicable towards anything on SQL DB today, as well as will be in Azure SQL today, and will be in SQL Server 2022 as well. So why query store hints? We've introduced Query Store with great success in 2016. Query Store hints enables you to identify and mitigate a problem in a really easy way. We had ways before, with plan guides and plan forcing in Query Store, but it was a little more complicated than kind of using a hint when you can for a specific query to improve performance, right? In cases where you cannot change application or application code, hinting is not possible very easily. And then when you want a more granular scope, you don't want to apply a particular option at the database level. So you want to apply it at a query level because that option, for example, let's take max degree of parallelism, might be a problem for one query or a subset of queries, not the system as a whole, right? So how do query store hints work? When queries are executed, they're stored and captured in the query store. Their plans are stored in query store. Their execution stats are stored in query store. When you create a query store hint, effectively that hint is applied to the query when the query executes, right? So what are hints that we can actually give? You can give things like option recompile. You can change compatibility level for a query. You can configure max stop for a query. And then there are a bunch of other things. You can force an index. All of those options are possible using a hint on a query store query, right? So I have just 2 slides, literally, and I'm going to go through 3 different scenarios of demos. The first one is going to be just an introduction to what you can do, simple set of queries. The other one will be a data load scenario, and the third one, time permitting, is a different scenario. So first one is, how do we apply query store hints? So let's go to a very simple kind of example. So I'm just going to clear this query store to make sure that I don't have anything remnant. And then I'm going to look at the property table. This is just a table that I have, where I have a stored procedure. So there are 3 indexes here. Of interest will be this agent ID because my statements use this agent ID, and I have a primary key on property ID. So those are 2 indexes of interest, right? And if I look at my stored procedure, and I'm showing you this in advance, shouldn't have put actual plan. Control 1. It is pretty simple, right? So you do a select where agent ID equal to a particular agent, right? So it's a pretty simple query. But this is your classic case of parameter sniffing that we see quite a bit, where you have a particular agent which is dominant in that data set. You can think of another data set being a country, right? You have US as majority of the rows versus other countries in your data set, so on and so forth. So let's execute a couple queries and see how this works, right? So I execute this property search by agent with agent ID 101. And it is executing. So first thing I look at is, it's still returning results. Couple more seconds, it should be done. I apologize. If you can't hear me, please let me know. I know it's loud out there. It is taking a little longer than I thought it would. What was that? Oh, you're done. OK, awesome. That's great. So if I look at the plan, so a couple of things I'm going to look at. So the plan for this is an index scan. And we'll look at stats in a second. So it's an index scan. It's a parallel index scan. And it is returning around I shouldn't look at this because the parallelism gather doesn't have the actuals, but I'll look at the sort. It's returning around 200,000 rows, right? So that's for agent 101. If I look at kind of some of the execution stats, it's 343 milliseconds. Elapsed time is a huge amount. CPU is not much at all. So what's the behavior today when I use the same procedure with another parameter? The behavior is I'm still going to use that plan, the same plan as before, because it was compiled with the first set of parameters. And this new set of parameters is still going to use that plan, even if it's not kind of efficient. Right? So if you look at this plan returns only 3 rows, yet we are doing a scan of the 200,000 plus table in order to return 3 rows. Right? And so looking at stats again, it's about 47 milliseconds, so on and so forth. And this elapsed time is 40 milliseconds only because I executed the first query, and so all the data is in your buffer pool. If it had to actually do remote I/O, the time would be a little more, right? So how do we actually figure out why these plans? If we look at these stats, the agent ID column, and this is a DMDB stats histogram is a function that allows you to get stats. It's kind of like DBCC show statistics on premise that you can use on Azure. So looking at agents itself, I'm just looking at this NCI property agent ID, which is an index, non-clustered index on agents. Agent ID 4 has 4 rows, and agent ID 101 was the previous execution, has about 190,000 rows, right? The classic parameter sniffing type problem. So what do you do if you can't control this code, right? It's a third-party app, or this code is being sent by, it's not a stored procedure, but it's being sent by the app, so you can't really, change it. So there are a couple of things you can do. You can recompile the proc as a DBA if it has not got, typical parameters. And if you do that and re-execute that, you see that the plan fundamentally changes because it was getting only 3 rows. It does a seek on the index, right? And then it's looking up the rest of the select list because it's just 3 rows. It doesn't have to scan the hundreds of thousands of rows that the table has. So we know that this is, from this we know that this is not a typical parameter. This is a skew. This value is skewed versus the rest of the values. So one of the options we can do, and we know that recompile actually would fix the plan in terms of would be recompiled for that set of parameters. So a quick way is we can apply a hint so that if you can't change the query itself, you can apply a hint to say that let's force this option recompile on this query without actually modifying the query. So what you have to do is you have to get the query ID of the query in question. And here, the query ID of this query is 1, right, in query store. And the way you get it is you go after sys.query store query text, join with query, and I'm doing just a search on a particular query ID. If you have a procedure, you can you do the same thing. The other way is you can sort by like CPU or things of that nature if it's a high CPU type scenario, which we'll look at in a second. Once you get the query ID, setting a hint is as simple as indicating what query ID and indicating what hint that is, right? So I set this hint. And once I set the hint, this is persisted across restarts. So this is not a one-time thing. This is persisted in query store, even across restarts. And you'll view the hint here, to say that this query ID, this query ID has a hint. The hint is so-and-so. And if the hint can be applied or not when the query is run, right? So let's run this query again. If I can. Let me actually clear the procedure cache because I had altered database, current database scoped, configuration, clear procedure cache. Let me just clear the procedure cache because I executed it after the recompile. OK, that's done. And if I execute now both these queries together, in the first example, you saw that the first query creates the plan, and the second one just uses the same cached copy of the plan, right? I think it's I don't know why it's taking a little longer than I thought it would, but there it is. you'll see that the plans are fundamentally different. In the first case, the plans were the same because the second execution would use the plan compiled by the first execution. But here in this, after I specified the hint, if I run these two queries individually, it recompiles for the second query because I've given that option recompile as a hint. So that's in a nutshell how you apply a hint. And we'll look at this in various scenarios. Other thing you can do is you can apply multiple hints if you want. I'm not going to do it in this example, but it's just comma delimited list of multiple hints if you want to apply multiple hints to a particular query, right? So it's not limited to just one hint. If we cannot apply a hint, in other words, you give a hint which is invalid for a particular plan, we'll just ignore the hint and move on with life. So we won't fail a query because of that. So that's the first basic example. Let's look at a more interesting example, which has to do with memory grants. So what are memory grants real quick? Memory grants is grants that a query requires to execute for things like hashes and sorts and the inner runnings of a query, right? There's limited amount of this workspace memory, and when you get a grant, you have to request for a grant, and then if there is memory available, this semaphore which governs this workspace memory hands out that memory available, right? And there are times there is a max that a query can ask for a grant, and there are times that there'll be queries, if you have high intensive queries, that will be waiting for this grant, right? And what weight you see in DMOS weight stats or any of the weights and queues methodology is this resource semaphore weight. So let's look at a ingest scenario that uses kind of this memory grant type stuff. So here I'm ingesting 8 files. Each of them are, oops, I didn't have the size. Each of them are 1.2 gig in size, so about 10 gigs of data, right? I have a Databricks notebook. I've already read the data, and I'm just going to bulk insert it into kind of a table, right? So all I'm doing is, at this point, I'm just bulk inserting. Don't worry about the mechanism. We won't focus on the Spark code. But all this does is it takes a data frame of data in the data lake and pumps it into SQL Server. So I am executing this. And let's look at what that looks like from a SQL Server perspective, right? I have a get request query, which we'll see. It's effectively just pulling out the right columns from the DM exec request to see what's running. And in the running queries, I'm going to see a couple of things. I see a ton of them. There are 32 parallel bulk inserts going on, and I see a ton of them waiting on this resource semaphore, right, which indicates they're waiting for a memory grant, right? And so what is this memory grant? Let's look at a couple other DMVs. So first thing is, cumulatively, how many grants are granted and how many people are waiting? So there are 12 grants which are granted out of the 32. The rest are waiting, right? So 30 to 20 people are waiting on a grant, if you will. And then, so this is got by this DM exec query resource semaphores DMV. And the second thing is, if I look at individual grants, you'll see a couple interesting things. This is another DMV which is very important for memory grants. They request about 3.5 gigs each, and some of them are granted, right? And the other ones aren't yet, right? Because there's nothing, no available memory to grant. And the interesting part is, there's a used memory KB. The used is nowhere close to the granted, for example, right? In this case, the used is nowhere close to the granted. It's much less. The reason they're throttled is they're throttled on since we have overestimated this grant, we have granted a lot of memory, the other queries are actually waiting on this grant. So how can we fix this? A couple of things we can do, first of all, to identify who are these high memory grant queries. We can use, query store again. Actually, we can use, first of all, DM exec request also has the memory grant, so you would be able to actually see what these queries are. And this is just joining the memory grants DMV with DM exec requests. This will give you kind of what those, things, and they're all bulk inserts, right? So bulk insert doesn't have an option. We have a query hint to actually hint what the memory grant should be, but bulk insert is not a scenario that has one of those options. So in Spark, I can't specify an option. Even if you're using the bulk insert T-SQL statement, you don't have that option. So how would I kind of resolve this issue? I use, I will use a QDS hint in order to do that, right? So let's look at how to use that hint and then rerun this thing. So I'm going to actually first identify this query. What is the query from query store that has the largest grants, and its query ID 34. And I'm going to use this option to say the max grant % is 5. So I limit the grant per query. I'm going to restop that ingest part because it didn't finish still. And I'm going to restart this. Control Z. And you will see if I do a get requests again, oops, if I can drag this out, none of these are waiting on a memory grant anymore, right? All these have been granted memory because I said the max that a query could get is only 5% of the total available memory. The default, the max is 25%. So this is another scenario. I can't change the app. I don't have a hint. I identify the issue. I apply it in query store. And, I see a performance boost. If I let this finish, actually, I want to proceed to the next slide just in case we have time. If I let this finish, this is the difference of kind of the load time, right? So with and without the hint. With the hint, it was half the time of the default configuration without the hint. It was able to generate much more log and consume much more of the resources. So this is another example of kind of using memory grants, in order to boost performance in a place where you can't, isolate in an application. So in this case, for example, looking at top resource queries in query store would show you the only one which is top resource is this bulk insert. And if you look at the T-SQL, this is not even a SQL statement, not a user executable statement, because this is the driver sending insert bulk. It's not bulk insert, it's insert bulk, if you see that, right? Because that's what Spark sends, or the, when you use SQL bulk copy API, that's what's sent to the, SQL Server. So that's the second thing. And let me check. I have another demo as time permits. Let's go to a third demo. And I think I'll be able to pull it off. So I have a application that I've written. And I see really quick that I reached the request limit of 1600. Right? So the application is failing, saying that I reached the request limit of 1500. I cannot at this point even connect to the server. If I try to connect to the server, it should fail if I can figure out where this is. Oh, it was able to work. Some of the connections at least will fail. Okay, so some of the connections, depending on the connections or not, but you see, many of them are actually failing. So a couple tips to give you when that happens. When you cannot connect to a SQL DB or database on Azure, or even on-prem, you can always use something called the DAC connection. I don't know how many of you are familiar. And the way you do that is you specify admin : so admin : and the server name, and that will give you a backdoor. Only a single connection can actually be connected to it, right? So it'll give you an in to the database even if you're out of workers. And then that would allow you to, in fact, go in and set your hints or any of the mitigation that you needed to do. I know I'm kind of out of time, or close to out of time, so I'm rushing this demo, but that's a way to the admin connection. I would go and actually set the issue there would be max DOP is set incorrectly. So I would go there and hint the query to actually have a degree of parallelism of 1. I don't know. I think this is a admin colon. So I think I'm right at time, so I'll take questions at this point of time. I don't think I can turn around and fix this demo. So few things to show you or demo at least. This. Yeah, I'm at time. So any questions? Feel free to hit me up. Thank you for attending. This 20 minutes is a whirlwind of a time frame to do 3 demos. I appreciate your attendance. Bye bye.